All right, so this week we're going to look at polar coordinates, okay, section 5.1. We're actually going to split this section over 2 days. Okay, so we'll do half today, half tomorrow. Okay, so previously, okay, in this class and probably all your other classes you've taken with math, you've used XY coordinates for graphing. Okay? That is on this kind of graph paper. Okay, you have an x-axis, a y-axis, and everything is set up as a rectangular grid. Okay? But we can also graph things in polar. Okay, polar, it's just a different type of grid, okay, different way to graph. Let me show you a polar grid. Let's see, background. All right, so polar looks like that. So instead of having a rectangular grid, basically you have a circular grid. Okay, and we call the point right in the middle, you can still call it the origin, but it's also called the pole. Okay, and we number in degrees going around the circle, starting with 0 on the right, 90, and we're going counterclockwise to 90 at the top. Keep going, 180 on the left, 270 on the bottom. Okay, this horizontal axis that we normally call the x-axis, in polar, they call it the polar axis. Okay, and just like a rectangular coordinate, there's 2 parts to it, but it's not an x and a y. Okay, x and y is when you're using rectangular graph paper. Okay, the 2 things that we need to write when we do a polar coordinate is r and theta. Anybody have a guess what r stands for when we're dealing with circles? Radius. Yep, r is my radius. And what do we normally use this Greek letter to represent in trig? Theta or alpha or beta, any Greek letter we usually use to represent an angle. So when you write a point in polar, those are the 2 things you need. How far is the point from the origin? What's its radius? And then what's its angle? And just like an xy coordinate, there's really 4 different cases. Your radius can be positive or negative, and your angle can be positive or negative. When you're dealing with xy coordinates, that puts you in different quadrants. Like if it's positive, positive, you're in quadrant 1, and so on. Okay, so I'm going to describe how you graph a point. Okay, first thing you do is you move out the number of rings indicated by r. Okay, so if I had a problem where r was 3, I'd be moving out to the 3rd ring. And there's 2 directions you can move. Right? Just like if x is positive or x is negative, it controls whether you move right or you move left. Well, it's a very similar idea. If my radius is positive, I start at the pole, start at the origin, and I go to the right. Okay, so if r is greater than 0, if it's positive, we go to the right. If r is less than 0, in other words, if r is negative, what direction do you think we'd move then? Left. Yep. And that's the first step. Okay, so if you were graphing like an xy coordinate, that's the first thing you do. Okay, you move left or you move right. And now we look at the second part of coordinate. Okay, we look at the angle. Okay, so after you do step 1, we have 2 directions we can move for theta. Now, when we move on an angle, we're moving on a circle. So we usually don't call it left and right or up and down. What are the 2 directions you can move on a circle? Yep, clockwise or counterclockwise. And the direction you move, it just depends on is theta positive or is theta negative. If theta is positive, okay, if it's greater than 0, you're going counterclockwise. That's this way. If theta is negative, Okay, if it's less than 0, you're moving clockwise. It's this way. And that's all you really need to know to graph a point. Okay, so what we'll do is we'll practice every case you could have. Positive radius, positive angle, negative angle. We'll do some angles in radians, we'll do some in degrees. Generally, if you have an angle in radians, the easiest thing to do is change it to degrees and then graph it from there. Okay, any questions on step 2? All right, so let's try graphing some points. Okay, they do have circular graph paper. Like if you just go online and you just search for circular grids, you can get like 4 or 6 of these printed on a single page. I have regular graph paper, but I don't have any circular graph paper. If anybody wants some, just let me know, and I can print it out. And after lunch, you could come back and grab it if you need it. All right, so we're going to graph the point 3, 120. Okay. First thing is on this graph paper, each line is 15 degrees. 15, 30, 45, 60, 75, 90. Okay. You can have more lines, you can have less lines. That's just what this graph paper is. All right, so I'm going to start with my radius of 3. Okay, Stephen, which way am I going to move? Because my radius is positive. Steve?
Which one? Move it out 3 lines.
Yep. Which one?
Thanks, Steve.
Which?
Right?
Nope, not up. What are our 2 choices for the radius?
Also right.
Yes,
Right.
left or right. In this case, it's positive, so we're going to go right 3 units. Okay. And now, Ashley, how many degrees am I going to move? How many degrees am I going to move? 120 degrees. Now I have 2 directions I can move. Clockwise or counterclockwise.
Clockwise?
This time it's
No, counterclockwise.
counterclockwise. Yep. Positive angle, counterclockwise. Okay, so I'm going to go 15, 30, 45, 60, 75, 90. And I need to go 30 more. 15 and 15 more. Okay, so that's 120 degrees to there. And that's it. That's how you graph a point. Any questions on how I got that point?
So we're not like making a triangle or anything?
Well, just graphing a point. There'll be triangles eventually during the week, but not yet. We always have triangles. Okay. Any questions on that? All right. Let's try 5 comma pi over 4. Okay, what might be a good idea to do on this one first? If you want to. It's not required. I won't ask you to on the test, but most people have an easier time visualizing in degrees.
How would you graph it if you didn't convert it?
If I didn't convert it, I would have to know this is 0.
Oh, you have to remember.
I'd have to know this is pi over 2, and pi over 4 is halfway between. But we can change to degrees. That's 0. That's 90. We're still going to do the same thing, except in degrees. What's pi over 4? 45. Which, as I just said, is halfway between. Okay. Let's see. How about Bailey? How many rings do I move out here?
5 to the
Yep.
right.
5 to the right. And then how many degrees do I move?
45.
And which direction?
Counterclockwise.
Perfect. That's it. Okay, we haven't come across this yet, but the radius can be a decimal. So if you had 5.5, you just go in between the 5th and the 6th ring, just like you would with graph paper. Okay, but I think most of the problems I give you are non-decimal for the radius. Questions on that one? All right. So now let's try a negative angle. 5, negative 210. Right, so Sydney, how many rings am I going to move out here?
5.
Yep. 5 to the right. And then Stephen, starting from here, how many degrees am I going to move?
I'm gonna go like that, so it's gonna be like the bottom. 180 is a flat line, so below 180, right? So it'd be like in the bottom left column somewhere.
Are you going clockwise or counterclockwise?
Counter.
Counterclockwise.
Should I go not counter or should I go counter?
You should go not counter.
All right, I'll go clockwise.
So why don't we go clockwise? So now, his reasoning was good though. If you go halfway around, that's 180.
Yeah,
And then how much more do you have to go to get to 210?
30.
30 more. 15 and 15 more.
Oh,
Okay, so we went 5 units to the right. And then we're going 210 degrees clockwise. Okay, because the angle is negative. Okay, any questions on that one? Well, it seems simple, but a lot of people mix it up on the test. They end up going the wrong way, put the answer in the wrong spot, just little mistakes.
So with the degrees, you go opposite, so negative, you go positive, clockwise.
Negative is clockwise, yep.
All right.
Positive is counterclockwise. All right, let's try negative 3 pi over 2. Yep, it's the same as 90 degrees. Okay, so this is our first one with a negative radius. Okay, so which way do we move for that? Yep, left, how many? 3. And then starting from there, we're going to go 90 degrees, which way? Counterclockwise. So we go to right there. So we went, I'll draw this one out. Left 3. Counterclockwise, 90 degrees. Okay, that's one way to get to that point. Can anybody give me a different way to get to that point? Okay.
Go positive 3 right.
Positive 3.
Maybe 270.
Yeah, that'll work. That's another way to get to the same point.
Or negative.
Positive 3. 270. All right. What's another way?
Positive 3 and negative 9.
Yep, that'll work. Positive 3. Negative 90. And there's one more. And you can find the pattern if you have a negative, positive, 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 negative. We know the last one, it's going to be a negative, negative. Yep,
Negative 3 and negative 270.
negative 3. Let's try it. Negative 270. Okay, so we're going to go left 3, and then negative 270 would bring me around clockwise. Okay, so how many different ways are there to get to that point? Or really any point? There's 4 different ways. Okay. Now, I wouldn't count, for example, going to the right and then making extra revolutions. That's not a different way. Okay, that's just repeating one of the 4 basic ways. Can you do that in rectangular coordinates? Like if I want you to get to, say, the point, let me just put the grid back up. How many ways are there to get to that point? Just one. Okay? 2, 1. That's the only way. If you want somebody to put a dot on that spot, that's the only way to do it. Okay? With polar, that's not true. Okay? There's really 4 different ways. All right, so why that's important is because if I give you a point and I graph it, and I ask you to identify the coordinates and it was a matching problem, I could pick any one of these 4 ways to write this coordinate. These are all correct. If I said to you, identify the coordinates of this point, You could write any one of these you want, unless I specifically say I would like a positive radius, positive angle. Then you have to do it that way. Okay. Questions on that? Okay. I think easiest way to figure out different ways to write a point, draw it. You could probably come up with formulas in your head like, oh, well, the difference between 90 and 270 is 180 degrees. Maybe you could find some patterns here. But for me, I always just make a sketch. All right, so we actually kind of just did this on the last one, but a negative, negative. Okay, anyone think they could tell me where I would end up if I did -2, -180? Macy?
You go left 2 and clockwise 180 degrees.
Yep. Now this is one that if you went clockwise or counterclockwise, you'd be lucky you'd end up at the same spot, okay, because you're going halfway around the circle. But technically it's left 2 and then that way to 180. I'm sorry, clockwise.
Oh, I was
Yeah, you were right, clockwise.
But either way, it doesn't matter. You're 180.
Yep, that's the direction. Okay, when you're sketching a point, generally you don't draw this. Unless somebody asks to show the direction, you don't have to draw that. Okay. Great, any questions on that one? Okay, so that's a negative with a negative. All right, let's try 0, 300. Okay, what do you think is going to happen here? Radius is 0, angle is 300.
Nothing because it's 0.
All right, so my radius is 0. So I stay at the origin, but then what about the 300? It's going to what?
Pivot 300 degrees in one spot.
Yeah, it's going to just pivot 300 degrees, staying in the same spot. Okay, so when you sketch it, you just put your pencil down and then turn your pencil 300 degrees. Make sure you just turn it 300 though. You know. Stay right there. Okay, so anytime your radius, yeah, you gotta do this pivot. Anytime the radius is 0, you're always right at the origin. All right. Let's switch it. Try 1, 0. Is this one going to be at the origin?
No.
No. Okay. How do I graph this one? Just go over 1 left or right? Right. Okay, so anytime that your angle is 0, you're always going to be on the horizontal line, either left or right. Okay, so that covers pretty much every case for graphing. Positives, negatives, and 0. Any questions on graphing a point in Polar? All right. Okay, so next part, I want you to try this one on your own. Okay, we already went through one similar. I'm giving you the point 3 pi over 6, which, if we want to change the degrees, what's pi over 6? Pi is 180. So 180 divided by 6. Okay, and I want you to write that point 3 ways. First way, I want you to tell me a positive radius, and I want an angle between 360 and 720. Okay. Second way I want to write it is I want a negative radius, but I want an angle between 0 and 360. And the third way, I want to write it as a positive radius, but now I want a negative angle between negative 360 and 0. Okay, so it's kind of like the one we just did. The easiest way is to make a sketch and draw it, and then you can see what your angle has to be. Your radius is always going to be one of 2 numbers. What are the 2 numbers your radius has to be? Either 3 or negative 3. Right? If your radius isn't 3 or negative 3, you're not going to be on the third circle. So you just have to figure out your angles. Right, so take a second, give it a shot, and then we'll go over it together. All right, so the first way they want us to do it is a positive radius. They just want us to make the angle bigger. All right, so first thing I do is just graph the original point. Right 3, 30 degrees. Okay? That's the point I want to get to every time. Right? Now, if I wanted to keep my radius positive, what number would it have to be? Yeah, it's got to be 3, comma. And now they want my angle to be bigger than 360. So what can I add to that that'll bring me around an extra time and exactly back to the same spot? Yeah, so just add 360, and that'll bring you around one extra time, and it brings you right back to the same spot. So, you could add 360 to that angle as many times as you want, and it's just going to keep bringing you right back to the same spot. Okay, any question on the first one? Okay, so if I were to draw it, it's really like this. 360 plus that little bit more is 30. It's 390. All right, next one. They want R to be negative. Okay, so what does my radius have to be this time? Yep, it's the only choice, -3. So I'm going to start from where that X is. And now I just have to figure out my direction. My angle is positive. Okay, which way do I go for a positive angle? Counterclockwise. So we just need to figure out what that is. What's halfway? And then each line is 15. So I've gone 2 more lines, so that's 180 plus 30, 210. Okay, any questions on that one? Okay, last one. What are we doing here? Positive radius. What's my radius? 3. So I'm going to start from right there, and my angle is negative. So I'm taking the long way around to that. So it's 30 degrees shy of going all the way around. Careful, what number? Negative 330. Yeah. Again, you could come up with formulas for doing this without a sketch, but I think a sketch is the easiest way. Okay, and if you want graph paper, just let me know and I'll print some out. You can get it after lunch. Okay, any questions on that?
Are we getting a worksheet or?
No, it'll be in the book. But the graph paper, if you want it, that would be separate. Okay, questions? Yes?
So when you find these, you're finding how far you have to go around to get to the original point?
To get to the original point, yep.
Okay.
Whether it's, do you go left and then the original point, you go right and then the original point, or do you go clockwise or counterclockwise? So you have four choices. All right, last thing for today. We're going to convert a point in polar back to what we're used to, rectangular. Right, so let's say that this point is on a circle of some unknown radius. So if I don't know the radius, how could I represent it? Sure. So this is your radius from the origin to the point. That's my point right there. R. And we don't know the angle either. Okay, it's just some angle. So how could we represent the angle?
Theta?
Yeah, generally we use theta. And my goal is to figure out how to change from polar, which is an R and a theta, back to what we're used to. Okay, what are the 2 letters we work with when we're doing rectangular? Okay, so somehow I have to turn R and theta into X and Y. So I have to figure out how far over and how far up. So, what do you think? I'm going to draw here? Yep, I want to know the height. That's the y value. Okay, and let me just make this in a different color. Okay, and what else do I want to know besides the height? Yeah, the left and the right. I want to know the distance. I know it's hard to see. I'll make it red from there to there. Okay, and I heard somebody use these letters X and Y. Okay, so those are the letters we'll use. So you're going to be given this in a problem, and you want to find that.
Are we
Right.
gonna have to do the email?
Convert back from rectangular to polar? Yep, not today. That'll be tomorrow. All right. So what kind of triangle did I just make here?
Right.
Yep, it's a right triangle. There's your 90 right there. So now what I want to do is use right triangle trig to figure out x and y using r and theta. Let's start with x. Okay. Is x the opposite, adjacent, or hypotenuse to theta?
Adjacent.
It's adjacent. It's right next to it. Okay. Is r the opposite or hypotenuse? Hypotenuse. So does anybody remember the trig function that has adjacent and hypotenuse in it? Cosine. Very good. Yep, cosine. So it's cosine of my angle equals, what's the side adjacent to theta? X. Adjacent over hypotenuse. What is my hypotenuse? R. Okay, and the last step, rather than writing it this way, I'd like to have x by itself. So it's x equals. So how do we put that r on the other side? Yep. Multiply by r. Multiply by r. And there's a formula for x. X equals r cosine theta. You'll be given r. You'll be given theta. Just type it into the calculator. All right. Now let's get a formula for y. What side is y? Opposite, adjacent, or hypotenuse? Yep, it's opposite. We already said r is hypotenuse. What trig function do you use with opposite and hypotenuse? Sine. Sine of theta equals, anybody tell me the fraction on the other side?
What was that? Over R?
Yep, opposite over hypotenuse. And if we do the same thing we did last time, what's y going to equal? Go ahead, Hunter.
R sine theta?
Yep, r sine theta. So to find the y value of your coordinate, take your radius and multiply by the sine of your angle. To find the x value, take your radius, multiply by the cosine of the angle. And it's the same formula as I just gave you. Okay. So you'll be given a point in polar. These are the formulas to convert to rectangular. Okay. Any questions on those two formulas? All right, so let's give them a try, see what we can do. Okay, convert the point 6 comma pi over 6 to rectangular. Now, if you don't want to convert pi over 6 to degrees, what could you do instead? Because you don't have to convert this. We just have to check something before we type it in on the calculator. Yeah, you could just check the mode on your calculator. Put your calculator in radians and do it that way. All right. Anyone think they can tell me the formula for x? You don't have to tell me what it comes out to, but just tell me it's what times the cosine of what. Oh, Emily? Mhm. Yeah, it's going to be 6 cosine pi over 6. Okay, and we'll figure that out in a second. Malin, can you give me my formula for y? Sine. Yeah, we're going to keep it in radians. Okay, if you want to change the degrees, that's fine. Change your calculated degrees and go from there. Okay, I'm already in radians, so I'm just going to type it in that way. 6 cosine pi over 6. Okay, for these, just round it to 2. Okay, 5.20. Okay, next one, that actually is going to come out to a nice answer. 6 sine pi over 6. It's going to come out to 3. And now the last thing is just write it as a coordinate. X, comma, y. Okay. Any question on that one? All right, let me graph this point in polar, and then let me show you something you can do on Smartboard or probably any computer. Okay, I'm going to graph the point 6 pi over 6. That's 6 30 degrees. 1, 2, 3, 4, 5, 6 to the right. And then up two lines is 30 degrees. Any questions on that point? Now, what I'm going to do is I'm going to take a rectangular grid. I'm going to drop it right on top of that one. And if I do it right, that point should look like it's a little more than 5 units right and exactly 3 units up. Okay, so I'm going to drop a rectangular grid right on top. And let's see if it works. Okay, does it look like that point is a little more than 5 units right and 3 units up? Yeah. Looks perfect. That's 5.2 units right, 3 units up. Okay, so it ended up exactly where it should have. Okay, so rectangular, polar. Actually, I used that one. Any questions on that? All right, so try the last one on your own, and then we'll go over it, and that'll be it. If you don't have a calculator, at least just try to set up your 2 formulas. All right, Jason, what'd you get for your formula for x? Perfect. Negative 4 cosine 120. Sometimes it comes out nice. Sometimes you get a decimal. We'll just have to see. Nick, what about your formula for y? Do you remember what trig formula we used besides cosine? Sine. So y is r sine theta. So what would you get for your formula for y? Yeah. And what's your angle? 120. All right. Now, when I type this in on my calculator, I'm going to leave it like that. What do I have to check? Make sure. Yes, I'm in radians. I got to change back to degrees. All right. Type it in. Negative 4 cosine 120. Okay, we get 2, which I think is what Jason said at first. I don't think the second one comes out nice. Does anybody have it? Wes?
Negative 3.46.
Negative 3.46. Okay, and the last step, just write it as a coordinate. Okay, I'm not going to graph it and show you that again, how you can drop the rectangular grid right on top, but it would work. Okay, any questions on that? All right, so we looked at basically what polar is, how to graph a point in polar. Okay, we practice all the combinations you can have, positive, negative, writing points in different ways. And then the last thing we did was how to change a point from polar to rectangular. Tomorrow we'll start with changing the other way. Okay? How do we change it from rectangular into polar? All right. And then we'll also get into Appendix 4. Right, so the homework in your book, okay, 308. Okay, all evens. Okay, 12 to 26 and 40 to 46. Again, that's all evens, no odd problems.